Welcome to my presentation. In this presentation, let us see some more methods as to how to find the inverse of a matrix. In my example 2, we mentioned about the Gauss-Jordan elimination method. There is another easier way to solve for the inverse of a matrix. Let me explain this. If we have a matrix A with elements A, B, C, and D like that, then the inverse of this matrix can be achieved as follows. We're going to write this as 1 divided by, we're going to multiply the major diagonal elements A times D, subtract the minor diagonal elements, which are C times B, and then we're going to multiply that by the elements which are arranged in this manner. So along the major diagonal we have A and D, so we're going to interchange their places. So instead of A we will write D, instead of D we will write A, and along the minor diagonal we have B and C, so we're going to keep the locations but change the sign. Since we have B in that place, we're going to write it as negative B, and in the place of C we're going to write it as negative C. So let me write this a bit more clear, and this is how we can achieve the inverse of the matrix. And there might be some restrictions to this. The restriction is these could be applicable to matrices with 2 by 2 or smaller sizes like that. But as the size becomes larger, then it becomes difficult for us to find the find an inverse of that matrix. So we have more advanced methods to find the inverse for a 3 by 3 and for a 4 by 4 and more than that type of matrices. So in here, AD minus CD, this is called the determinant. We'll talk about those in my determinant video presentations. But for now, let us apply this concept to an example problem. We will take the same example as what we have solved in our example 2, and then try to see whether we can apply that to find the inverse of that. So the example we had was, if A is a matrix, let me clean this thing up. If A is a matrix which has elements 1, 4, -1, and -3 like that, then if we want to find the inverse of this matrix, this is the procedure we're going to follow, the one which we just talked about. And in here we said the inverse we can write as 1 divided by the product of the major diagonal, which is going to be 1 times -3, minus the product of the minor diagonal, which is going to be -1 times 4, and then we're going to multiply that by the elements which are arranged in this manner. Along the major diagonal we have 1 and -3, so we're going to interchange those locations. So 1 becomes the -3 comes to the beginning of the major diagonal, and then 1 goes to the bottom of the major diagonal like that. And then along the minor diagonal we said we're going to retain those places of those elements, but we're going to change the sign. The +4 becomes a -4, and the -1 becomes a +1. So that is the way we can write it out. And now if we were to come back in here and then simplify this some more, this is how it's going to look like. 1 divided by 1 times -3 is -3, and then -1 times -1, negative times -1 is +1, +1 times 4 is +4 times, and then -3, -4, 1 and 1. And then therefore here we have 1 divided by -3 plus 4 will be 1, and therefore negative 3, negative 4, 1 and 1. 1 divided by 1 is 1, and therefore we need not have to write that. Therefore negative 3, negative 4, 1 and 1. So this is the inverse, and this is exactly what we had in example 2 as well. So there are several ways to arrive at the inverse of a matrix, and we have seen several of those methods in the examples which we talked about in our earlier examples. In my next presentation, we shall look at some more examples to see how we can find the inverse of a matrix, this time with a 3 by 3 matrix.